The interstellar comet 3I/Atlas has rapidly become one of the most baffling and hotly debated objects in modern astronomy, leaving researchers puzzled as they examine its sudden brightening, its striking electric blue glow, and its strangely rhythmic jets of gas that seem to behave more like controlled bursts than the chaotic outgassing normally associated with comets. When the object was first detected by Hawaii's Atlas Survey Telescope, it appeared to be just another visitor from beyond the solar system, similar to the interstellar objects known as Oumuamua and 2I/Borisov. Yet within weeks of careful observation, scientists realized that this comet was displaying behavior unlike anything previously recorded. The situation grew even more perplexing when NASA, the European Southern Observatory, and several independent observatories began collecting data that showed the comet not only brightening at an extraordinary rate, but also emitting pulses of gas that altered its trajectory in ways that defy standard cometary physics. According to researchers at NASA's Jet Propulsion Laboratory, the comet generated a series of short, rhythmic bursts in late October that caused measurable deviations in its path. These bursts were particularly strange because they occurred in the absence of solar heating, which is typically the driving force behind comet outgassing. Normally, a comet warms as it approaches the sun, causing its icy surface to vaporize and produce jets that can push the object slightly off course. But 3I/Atlas was far too distant for sunlight to trigger such reactions. Instead, the emissions originated internally, suggesting a chemical, thermal, or possibly structural mechanism at work within the comet itself. This behavior immediately raised eyebrows among astronomers, especially after Dr. Elena Markov of the European Space Agency remarked in an interview that the comet appeared to be correcting its own course, a description startling enough to ignite speculation about whether the motions were natural or something more unusual. Despite Markov's caution that most researchers are still looking for natural explanations, her comment nonetheless reflects the profound uncertainty surrounding the comet's behavior. The possibility that an object could show propulsion-like behavior without external influence pushes the boundaries of what is currently understood about cometary materials and the physical processes that govern them. As some researchers have noted, one plausible explanation is the venting of supervolatile materials such as nitrogen, carbon monoxide, or other exotic compounds that can sublimate at extremely low temperatures. These substances could vaporize even in the deep cold of interstellar space, producing thrust-like moments that could mimic controlled propulsion. However, even this scenario fails to fully explain the rhythmic regularity of the bursts, which seem more deliberate than the chaotic and uneven outgassing usually seen in comets. Adding to the mystery is the comet's dramatic and sudden brightening. Data collected by the Minor Planet Center showed that 3I/Atlas increased in brightness nearly tenfold in just 48 hours, an extraordinary jump that cannot be explained by reflective changes, solar illumination, or the simple release of dust. For a comet at its current distance, such a spike in luminosity implies a major internal event. According to planetary scientist Dr. David Jewett of UCLA, this abrupt brightening suggests something inside the comet is evolving rapidly. Jewett, who was involved in the discovery and early analysis of the interstellar object Oumuamua in 2017, pointed out that 3I/Atlas may be undergoing an internal transformation that has not been observed in other comets. He suggested that the comet could be venting volatile materials never previously detected or undergoing a partial structural collapse, either of which would dramatically alter the surface and internal pressure dynamics of the object. Jewett emphasized that such a transformation reflects processes not yet understood, underscoring the uniqueness of 3I/Atlas. Yet perhaps the most visually striking and scientifically perplexing feature of the comet is its brilliant electric blue glow. Observatories in Chile and Hawaii captured images showing the comet surrounded by an aura of luminous blue light. While comets often appear green due to diatomic carbon molecules fluorescing in sunlight, the coloration of 3I/Atlas is entirely different. Spectroscopic readings reported by Sky and Telescope reveal that the comet's coma is dominated by ionized nitrogen and oxygen, producing a blue spectral signature that has never been documented in any observed comet, whether solar system-borne or interstellar. This discovery alone has significant implications, as the presence of these ionized gases suggests chemical reactions or energetic processes that are highly atypical for a comet, especially one so far from the Sun. Dr. James O'Donnell of Cambridge University commented that the blue coloration acts as a chemical fingerprint unlike anything seen before, implying that the comet's composition may be far more complex and reactive than previously assumed. The combination of unusual propulsion-like jets, unprecedented brightening, and a chemically anomalous glow places 3I/Atlas in a category of its own. Astronomers are now faced with multiple intersecting mysteries. What internal processes could generate rhythmic bursts of gas without solar influence? What mechanisms could cause a tenfold brightness increase in just 2 days? And what conditions could produce a blue spectral signature dominated by ionized nitrogen and oxygen rather than the more common carbon compounds seen in typical comets? Each anomaly challenges long-held assumptions about cometary behavior, especially in interstellar objects, which are already rare and poorly understood. Only a handful of interstellar visitors have ever been documented, and each one has challenged scientific expectations in different ways. Oumuamua, for instance, generated global debate with its odd shape, non-gravitational acceleration, and lack of a visible coma. Now 3I/Atlas appears poised to surpass even Oumuamua in complexity, offering researchers an opportunity to expand models of how such objects form, evolve, and behave across vast cosmic distances. Scientists are now working with data from multiple observatories and space agencies to construct a comprehensive picture of the comet's composition, trajectory, and internal dynamics. Advanced spectrographs, thermal imaging tools, and long baseline telescopes are being employed to monitor the object as it continues its approach through the solar system. Researchers aim to determine whether its behavior stabilizes, becomes more erratic, or reveals further surprises. The rhythmic bursts remain one of the most puzzling features, and ongoing analysis is seeking to determine whether they follow a predictable pattern, whether they correlate with internal temperature readings, or whether they could be linked to a rotational process within the nucleus. If the bursts are tied to internal cycles, they could help scientists map the internal structure or identify reservoirs of supervolatile materials. If, however, the bursts show signs of modulation or patterning that do not align with natural rotational dynamics, the mystery would deepen further. For now, astronomers are urging cautious interpretation, recognizing that extraordinary observations do not automatically imply extraordinary causes. Even so, the behavior of 3I/Atlas is testing the limits of natural explanations. Whether the comet ultimately proves to be a rare example of extreme chemical volatility, an unusual structural anomaly, or something fundamentally new in astrophysical phenomena, it is already reshaping scientific discussions about interstellar objects. Its discovery has sparked renewed interest in studying such visitors, emphasizing the need for rapid detection systems, improved spectroscopic capabilities, and missions capable of intercepting and analyzing objects passing through our cosmic neighborhood. Whatever the final explanation turns out to be, 3I/Atlas has already captured the imagination of scientists and the public alike, serving as a vivid reminder that the universe still holds mysteries capable of challenging even our most advanced theories.